In this video, we're going to be looking at constructing and interpreting a binomial distribution. So this problem says, according to a survey, about 33% of people ages 16 and older in the U.S. own an electronic book reading device or e-reader. You ask 6 randomly selected people ages 16 and older whether they own an e-reader. Create a table of the binomial distribution for your survey. Round all numbers 3 decimal places. Okay, so looking at this, we're doing a survey. We're asking 6 random people whether they own an e-reader, and we want to create a probability or binomial distribution for the survey. So first I'm look, okay, so what are my number of successes? The number of possible successes I have that the 6 people I survey have an e-reader. Well, I could have that none of them do, so I can have k is 0, that 1 does, or 2, 3, 4, 5, or that all 6 have one. So those are my number of successes. Now I need to find the probability of each k. And so remember, that is when we're going to have to use our formula from up here. So I'm going to rewrite it right here. That probability of k is equal to nck p raised to the k 1 minus p raised to the n minus k. So here my n that I have is 6 because I am surveying 6 people. My k is going to be all of these possibilities. And then I need to figure out, okay, what's my p and what's my 1 minus p. So p, remember, that's my probability of people having an e-reader. And it says in my problem that 33% of people have an e-reader. So I'm going to go ahead and change that to a decimal. So that means that p is 0.33. Then we're plugging into that formula. And so that means that 1 minus p is going to equal to 1 minus 0.33, which is equal to 0.67. And so now I can go ahead and find my probability. So my first k is 0, so I have a probability of 0. Or I can write that k. Yeah, we'll just leave it at 0. And that's going to equal to, so my n is 6, so I have 6, c, k is 0, p is 0.33, raised to the k, which is 0, and then 0.67 raised to the 6 minus k, which is 0. And so I want to go ahead and type that into here. So here I have, instead of 30, I have 6, 0.33, 0, and then 0.67, 6 minus 0, which is just 6. And so rounding that to 3 decimal places, this is going to be approximately 0.090. I'm going to put that in this table. And I'm going to do that with k is equal to 1. So probability of 1. So now it says 6c0, I have 6c1. 0.33 raised to the first. 0.67 raised to the 6 minus 1. And now I'm going to replace all of these numbers here. So I have 1, 1, 6 minus 1, which is 5. And so rounding that 3 decimal places, I get approximately 0.267. And I want to keep going in this manner. So now I have 6c2, 0.33 raised to the second power, 0.67 raised to the 6 minus 2. So 6 minus 2, I get 4.33 raised to the second. That changed to 2. And so I get approximately 0.329. Probability I get 3 successes is 6c3, 0.33 raised to the third power, 0.67 raised to the 6 minus 3. And so plugging those in, I get approximately 0.216. Probability of 4 successes would be 6C4, 0.33 raised to the 4th power, 0.67 raised to the 6 minus 4. So 6 minus 4, I have 2. Change this 3 to a 4, and this 3 to a 4, and I get approximately 0.080. Probability of 5 successes is going to be 6C5, 0.33 raised to the 5th, 0.67 raised to the 6 minus 5. So changing my numbers here. 6 minus 5, I get 1, and so I get 0.016. And then probability of 6 successes, 66, 0.33 raised to the 6th power, 0.67 raised to the 6 minus 6. And so plugging those in, I get that this is going to be approximately 0.001. So things you notice, we just go up 1 each time on the K value for my combinations here, starting at 0. Same thing with the 0.33, it started raised to the 0 power and it goes up 1 each time. 0.67 is going to start at the 6th power and go down 1 each time. So that's kind of a pattern that we see there. And then if you notice, if you were to add up all of these, it would end up getting you approximately 1. It may not be slightly 1 because we did round. And now let's answer some questions based on our distribution here. So first, what is the most likely outcome of the survey? And so the most likely outcome of the survey is the value of K for which the probability of K is greatest. And we see that it is greatest when K is equal to 2. And so that means the most likely outcome is that 2 of the 6 people own an e-reader. So 2 of the 6 own an e-reader. And that's because that the probability of 2 is the greatest. And then it says, what is the probability that at most 2 people own an e-reader? So at most means less than or equal to. So we want to find the probability that K is less than or equal to 2. So that means that the probability that K is equal to 0, or the probability that K is equal to 1, or the probability that K is equal to 2. So I'm just going to add up all those probabilities. Well, the probability that K is equal to 0 was 0.090. Probability that K is equal to 1 is 0.267. And probability that K is equal to 2 is 0.329. And so when you add all of those up, you get 0.686. So there's about a 68.6% chance that at most 2 people own an e-reader.